Welcome back to my channel. I am Mario Mamalis and my goal is to share app dev technology topics that I find interesting. In this screencast, I will present the basic concepts of Azure DevOps services. The goal is to showcase the Microsoft development ecosystem and in particular the seamless integration between Azure, Visual Studio, and Azure DevOps services. My favorite definition of DevOps is people following a process enabled by products to deliver value to end users. The products I'm about to showcase are a perfect example of how we can utilize technology in our development process in order to develop quality software. Although I will be covering the basics in this screencast, I think you will walk away with a good understanding and enough interest to explore these tools for yourselves. I will cover more advanced DevOps topics in future screencasts. I hope you enjoy this. As always, please do not forget to subscribe to my channel and enable notifications for future content. Let's get started. Here's what I'll be covering. First, I will explain what the Azure DevOps product is and what services it offers. Then I will create an out-of-the-box web app with Visual Studio, the premier Microsoft IDE. I will then use the Azure portal to create an app service and a web app that will host our application. Then I will showcase how you can easily deploy your code to Azure directly from Visual Studio. Then we will create an Azure DevOps project in order to add some process around our development effort. On DevOps, I will first utilize Azure Repos for version control. I will then introduce continuous integration with Azure pipelines. I will spend some time explaining the basic YAML syntax of an Azure pipeline. And finally, I will modify the basic pipeline and add the ability to execute unit tests as part of the build process. So what is Azure DevOps? Azure DevOps is a web portal that offers a set of important services as a complete package for modern application development. Before Azure DevOps was introduced, development teams would typically use multiple tools to cover the different disciplines required to develop software. With Azure DevOps, the whole team can collaborate using one product. It supports and simplifies tasks performed by project managers, business analysts, developers, QA analysts, and ops engineers. More specifically, with Azure boards, we can deliver value to our users faster using proven agile tools to plan, track, and discuss our work across teams. With Azure Repos, we get unlimited cloud-hosted private Git repos and collaborate to build better code with pull requests and advanced file management. With Azure Pipelines, we can build, test, and deploy with CI/CD that works with any language, platform, and cloud. With Azure Test Plans, we can test and ship with confidence using manual and exploratory testing tools. And with Azure Artifacts, we can create, host, and add artifacts to our CI/CD pipelines with a single click. Okay, first let's create a solution for our project. I will use Blazor app as a template. Blazor is a single-page app framework for building web apps with .NET utilizing WebAssembly, which means that you can run C# code directly on the browser and you don't have to use JavaScript anymore. All right, the solution is ready. The project is there. Let's run it. And we can confirm that the app is working properly on the local machine. I'm going to switch over to the Azure portal where I will create the resources needed to deploy and run the web app. I'll create a new resource group under the appropriate subscription. And under the resource group, I will create a web app, which is the cloud-native PaaS offering on Azure for running web applications and APIs. It needs a unique name, and I will use .NET Core 3.1, which is only available under Linux at the moment. And we will need a new app service plan for the web app to operate under. And of course, we'll use the free tier for this demo. Okay, I'll go ahead and start the creation of the resources. And there it is. The Blazor version we're using is the server version, and for that we need to enable WebSockets. And lastly, I will set the app to run under HTTPS only. Okay, back to Visual Studio, I will create a published profile to deploy the code to Azure. We can see how seamless the integration is between the IDE and the Azure portal. Profile is ready. I will go ahead and publish. This is really very convenient. And the app is deployed and we can see it running on Azure. In order to protect and share the code with the development team, we will create a project on Azure DevOps. I'm logged in my organization where I have multiple projects, and I will create a new project. We'll give it a unique name, select private as the visibility, Git as the version control, and under work item process, I will select a custom process that I have based on the Agile default process. You could select any of the provided processes and customize it as you want. Okay, on the landing page, on the left, we can see the navigation where we have boards for work item tracking, repos for code version control, pipelines for CI/CD, test plans for quality control, and artifacts for package management. Let's take a look at the settings. Under overview, we can see that we can turn services on and off. Under teams, we can see the default project team, and me as a sole member, I will add one more developer so that we can feel like a real team. And then under permissions, I will add myself as a build administrator so that I can set up CI/CD pipelines. And that is all we need for now. A DevOps project can have multiple repositories. For example, one for the web app, one for an API app, one for your infrastructure, ARM templates, etc. I will create a repo for the web app, and as a good practice, I will include a README file and a Visual Studio Git ignore file to keep things organized. I prefer to keep my code solution small and the repos for each solution separate as opposed to one repo for everything. So I will go ahead and delete the default repo that was created when the project was created. Okay, and now we can examine the repo that we created for the web app, and indeed the files that we added are there. Now let's sync the code on my local machine with the remote repository we just created. For that, I need the repo URL. And on my local folder, I will first do a git init to create a local repo, and then I will sync with the remote repo master branch. I will do a commit of all the code that I currently have, and then I will push to the remote repo master branch, and everything seems to be good. Now we'll go back to the repo on Azure DevOps, and all the files are there. Time to introduce a continuous integration pipeline in our DevOps process. Since our code is in a Git repo, we will use Azure Repos Kit as the source. And since our web app is targeting .NET Core, we will select the ASP.NET Core template. The default YAML code is adequate to use without modification as a first step to enable automated builds. I will save and run the pipeline. And we can see that a build was kicked off. We can drill down to see the execution steps. And confirm that indeed the code builds fine. I will do a git pull in order to get the latest code locally, and then open Visual Studio and add a unit test project. We'll use XUnit. Just for demo purposes, I will add a very simple test. And first I will run the test locally. And surprisingly enough, it passed. When I executed the pull, I got the latest code including the YAML pipeline file. I'll open the file in Visual Studio Code, which has great support for YAML files. Let's examine the YAML to understand the basic syntax. Typically, most pipelines will contain multiple stages and multiple jobs within each stage. For example, you can have a build and a deploy stage. We will cover more of that in a more advanced screencast. Since this is a very simple pipeline with only a build stage that has one job, both the stages and jobs keywords are omitted from the code. First off, we have the trigger keyword. This is used to specify which branch will trigger the pipeline to execute. In our case, we only have one branch, and that is the master branch. The pull keyword specifies which VM image the build agent will run. In this case, we use Ubuntu latest. But we could very well use Windows since .NET Core is cross-platform compatible. Under variables, we have one variable defined as the build configuration, and it holds the value release. This can be used anywhere in the YAML code. The steps keyword is necessary because a pipeline requires at least one step. Steps can be tasks, scripts, or references to external templates. In our case, we have one script step that executes the command .NET build using the build configuration variable. I will modify the template to include two new steps. First, under steps, I will add a task to specify that we want to build the code with .NET Core SDK 3.1 and above. Then I will add a task to run the unit tests right after the .NET build step. As always, we add a descriptive display name. Okay, this task will look for any CS project file that ends in tests in one subfolder below the root solution folder. And it will execute under the specified build configuration, which in this case is the release configuration. I will push the code to master on the remote repo, always executing a git pull first. And back on the DevOps portal, we can see that the CI build has started. Examining the steps, we can see that the 2 new steps that we added in the YAML file are included. And again, the build was successful and we have added some automated unit test execution as part of the CI build. And this brings the Azure DevOps basic concept screencast to a conclusion. Please do not forget to subscribe to my channel and stay tuned for more Azure related content coming soon. Until then, take care and thanks for watching.